In mid-August, millions of students will re-enter classrooms. These students are returning at a time when the Delta variant of COVID-19 is circulating. The Delta variant is about 50% more infectious than the Alpha variant, which was about 50% more infectious than earlier strands in the United States. Children below age 12 do not have an option for vaccination yet, but they're at particular risk for both acquiring and spreading disease. We are COVSIM, composed of research faculty from North Carolina State University, University of North Carolina, East Carolina University, and Georgia Tech University. We are one of the teams chosen nationwide by the Council of State and Territorial Epidemiologists and the CDC to support forecasting, analysis of interventions, and communication with key stakeholders regarding COVID-19. Recently, we developed a simple model to illustrate COVID-19 spread within a hypothetical school over the course of a semester, given different assumptions regarding mask usage, incoming protection, and testing policies. Let's imagine a school with 500 students. At the start of the fall semester, a handful of students are infected with COVID-19. Also, some fraction of incoming students are already protected from COVID-19, either from receiving the vaccine or from prior infection. For the sake of simplicity, these students are perfectly immune from infection. In other words, we assume they cannot get the infection again. Estimated based on current vaccination rates and reported cases in North Carolina, levels of incoming protection differ depending on the type of school. 50% representing high schools, where all students are old enough to receive the vaccine, 30% for elementary schools, where no students are vaccine eligible, and 40% reflecting a middle school, where some students are eligible for the vaccine. Throughout the semester, let's also assume one case of COVID-19 enters the school per week to reflect new infections occurring outside of school, for example, from soccer practice, church gatherings, birthday parties, etc. Also, let's say that every week the school can randomly use RT-PCR, or real-time reverse transcription polymerase chain reaction, commonly used molecular tests for which results can be typically attained within 1 to 2 days, to screen a fraction of the student population. Students who don't receive testing are never put in isolation, regardless of disease status. Students who receive testing but are uninfected are also never put in isolation. However, those who are infected and receive testing have a high probability of being put in isolation, ranging from 70% to 90%, depending on whether they're asymptomatic or symptomatic. These students remain in isolation until they are fully recovered. Infected students who test positive and are isolated can no longer infect susceptible students. Alternatively, infected students who do not test positive have the capacity to continuously infect other students until they eventually recover. Testing is random, such that case investigation of potential contacts is not conducted. In the next video, we'll describe what our model predicts about the spread of disease within this hypothetical school under different scenarios.